Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 24 of the January daily Leetcode challenge. We are almost in the last 7 days. So let us quickly see today's question. From the last few days, actually, we are getting medium level questions. And again, today we are having a medium level question. It is a very good question to start with. If you are someone who is a beginner, it's a very good question to start with. This is some of this I can say is one of the beginner level question in graphs. Okay. So let us see this now. So like if you're not sure what is a graph, just go and Google it out. You will you should be knowing like what is in order and like some of the terms, okay, which are very generic. You can just know about them. That will give you some idea of what is happening in this question. Okay, that will give you like some hints how to begin with this question. Okay, fine. Now coming to the exact question, if you see the diagrams what we are given, so this is a graph, and as you can see, these are directed edges. Okay, directed means only in one direction you can move. Okay, so if you see for edge 0, see this whatever index 0, whatever you're seeing the values, it means that from edge 0 we are having edges to these nodes. Okay, for example, see 0 to 1 and 0 to 2. So that's why in the graph of 0, okay, if you take the 0th element of the graph, there is array. This array tells us which all elements receive the edges from 0. Similarly, if you see this tells us which all elements receive the edges from node 1. Okay, similarly. Okay, so the length of this graph will tell you how many nodes are there, and each value here, okay, each for example, graph of 0, graph of 1, graph of 2, these will tell you the edges which are coming from that node. Okay, simple as that. For example, graph of 1 is going to have an edge, sorry, node number 1 is going to have an edge towards 2 and 3. Okay, if you see edge number 1 is having a node towards 2 and 3, and so on. Okay, so this is one. So what we have to return is we have to return some of the, like, okay, let's see the question here. See, they are telling that we have to identify a terminal node. Once you get a terminal node, so whichever node has a directed edge, okay, which ends towards a terminal node, which ends in a terminal node, that you have written in the answer and in the ascending order. Okay, so I'm just giving you a gist of the question. If you want, you can pause the video again, rewind and like see it again. But yeah, this was the gist of the question. And now the actual details that I'm mentioning, I'm just going to read that. Okay, so it's question 802: find eventual safe states. So there is a directed graph of nodes, and each node is labeled from 0 to n minus 1. The graph is represented by zero indexed 2D integer array graph, where graph of I is an integer array of nodes adjacent to node I, meaning there's an edge from node I to each node in graph of I. Okay, so see this part. This is the index number 1. That means index, that is node 1 is having edge towards 2, node 1 is having edge towards 3. Okay, similarly node 0 is having edge towards 1, node 0 is having edge towards 2. Okay, that's what they're trying to tell you. Now if you see this part, a node is a terminal node if there is no outgoing edges. Okay, see here again the same topic becomes what is in order, what is out order of a node. You have to know those topics. Even if you don't know, still you can like think of what is happening. But yeah, it's better to learn those technical terms also. That will give some idea of what is happening there. Okay, yep. So they are just telling that a terminal node is something which doesn't have any outgoing edges. So what is outgoing edge? Outgoing edge means from that node there are no edges starting. Okay, as simple as that. A node is a safe node if every possible path starting from that node leads to a terminal node. Okay, or another safe node. So please try to understand what is happening. For example, see this part. If I'm at 2, okay, let's see this 5. 5 is a terminal node. Do you agree with me? 5 and 6, you can directly say that they are terminal node. Right? See this part. 5 and 6, if you see, there are no outgoing edges at all. Okay, so yeah, so that means they are definitely terminal nodes. Now if you see, if you talk about 4, 4 has edge. Okay, it's not like 4 doesn't have edge. 4 has edge, but the edge is going to the terminal node. Okay, so if you see this condition getting satisfied, they're saying a node is a safe node if every possible path starting from that node leads to a terminal node. Okay, so if you see the path starting from 4 leads to a terminal node in this case. Okay, similarly if you see for 2 also, if we start from 2, we are going to end up only in 5. Okay, there is no outgoing edge from 2 other than that. Okay, only it's going to 5, and since 5 is a terminal node, so we can say 2 is also a safe node. Okay, so that is something. So we have learned two terms. One is a terminal node. Terminal node is something which doesn't have an outgoing edge, and then a safe node. Safe node is something, if you traverse a path starting from a safe node, you will end up in a terminal node. Okay, as simple as that. And remember, this word is very important. Every possible path, remember this word is very important. Okay, for example, let us say from a edge, from a node there are 3 to 4 outgoing edges. All of them should end in a terminal node. Only then that particular node will be called up as a safe node. Okay, so every possible edge, sorry, every possible path, this has to be satisfied. Okay, every possible path from that node should lead to a terminal node. Okay, as simple as that. Indirectly, and when I say terminal node, I mean indirectly, because if you see, they are saying, see, from a safe node you can go to another safe node and so on till that safe node reaches a, from that safe node reaches a terminal node. Okay, as simple as that. So it need not be directly to a terminal node, but you indirectly have to reach a terminal node, right? Return an array containing all the safe nodes of the graph. The answer should be sorted in ascending order. Okay, yes, as simple as that. Now if you see the constraints, So see this part, we are going to have around 10 power 4 nodes, okay, as simple as that. And yeah, the number of edges are going to be in the range of 1 into 10 power 4, okay, as simple as that. So both of numbers are very high, so you obviously cannot go for a brute force approach. This is as simple as that, right? So now let's see the example number one first. So in this, as I mentioned, 5 and 6 are direct terminal nodes. Since a terminal is also going to be a safe node, what is safe node after all? Every terminal is going to a safe node. Do you agree with me or not? Just read this part. I'm sure you will get to know what I'm saying. Okay. Every terminal will obviously be a safe node, right? So 5 and 6 we can directly write in the answer. Other than that, see this case. From 4 we can start, and the only possible path is towards 5. Since 5 is a terminal node, you can write 4 also as a safe node. Next, coming to 2, as you can see, if you start from 2, again we are going to end up in 5, which is a terminal node. So 2 is also a safe node. Okay, as simple as that. Yep. So, yep, we are good then. So this was all about this question. Now, how to solve it? See, there are multiple ways to do it. Like you can, record, like just traverse the graph and multiple stuff you can do. Okay, all that stuff you can do. But only thing that I want to tell you is that, okay, yep. The only thing that I want to tell you that, see this case, it has to be done in such a way that you don't end up in loops. Okay, if you see this case, they have somewhere mentioned, I guess, yeah, in the, yeah. Okay, there it obviously is going to have a self loops. Self loop means that there are two cases here. For example, from 4 towards 4, okay, that is one example of self loop. Other than that, there could be circles or loops. Okay, so for example, 4 to 5 and then 5 back to 4. Okay, if you see in this case, yeah, 0 to 1, 1 to 3, and 3 to 0. Okay, there is a loop here, 0 to 1, 1 to 3, and 3 to 0. So you should not be stuck in those loops. Okay, you can do the decent DFS because any traversal you want, but only thing is you should ensure that you are not getting stuck in the loop. Okay, either it could be self loop or it could be a loop involving multiple nodes, right? So now my solution I am going to show, this is going to be the most optimal solution. Okay, as you can see, the space and time complexity, we are see m is going to be number of edges, and is going to be number of nodes. Okay, so see my solution. Let me zoom in and let us begin. Yeah, so yeah, I will go show you both Python and Java solution, and I will be showing two versions of my Python solution. Okay, so this was the Java solution, I will come to that, but before that, just I will show you the Python solution also. So we are just capturing the length. Okay, now for every node, I am see, this terminal node. I am creating array whose length is going to be n. That is, for each node there is going to be index. Okay, initially it will have only -1 as the values. Okay, as simple as that. So what is the meaning of that? So okay, I have written here. Let me show you this part. See here, this is the terminal node. Okay, this is going to be integer array, and it is going to have n elements. So the values here, initially it will have -1. -1 means that it is an unprocessed node. Okay, 0 means that, see, once the value becomes 0 for any index here, it means that it is not a safe node. And similarly, when the value becomes 1, it means that it's a safe node. Okay, these are some of the terminology that we're going to use. Okay, these are some of the I can say, like, a description. Just I'm providing a description of what I'm going to code. Okay, yep. Now let me show you the solution. So see, this is the function that I'm going to use. Okay, yeah, this is the function. Okay, so if you see this function, what is happening? See, first see the how the function call is happening. This is the function. Okay, let me zoom out a bit and I can show you the whole thing at once. Yeah, so this is the function, and this is the function call bit. Remember, this is a recursive function and this is the function call, right? So let me show you what is happening. See, I am passing a node. Node means, say, like, as you can see, these are some of the nodes here, like 1 to 3 and 0 to n minus 1, right? So this is good. This is going to be the node. I'm also passing a visited set here. Okay, and this is initialized with empty set, right? When the value is not passed, this default value will be used. Okay, as simple as that. Now what is happening? See, these are some of the terminating conditions. Remember, this is a recursive function call, so there has to be some of the terminating conditions here. Okay, so these are some of the terminating conditions. See this case, if terminal node of this is not equal to -1. See what will happen. Initially, all of them are going to -1, right? So let us say the value is not -1. Okay, as I showed you, there can be two other possibilities. Either if it is 0, that means it is not safe. If it is 1, that means it is safe, right? So once we know that, okay, then we don't have to traverse that node further. Okay, we already know that what is whether it is safe node or not. So if the value is not -1, that means it is either 0 or it is either 1. In that case, we should return that value itself. Okay, no need to proceed further. Simply return the value as it is. Okay. So by now you would have understood that, see, this function is going to return either 1 or 0. Okay, these are the only two values this function is going to return. If this function returns 1, okay, that means the node is a safe node. If this function returns 0, you will get to know that this is not a safe node. Okay, this is how it is going to work. That is how I have designed it. Okay, now this is the first ending condition, terminating condition. See the second terminating condition. This will actually verify if this is going to be a terminal node or not. Okay, see this part. If the length of See, graph of node I, if the length is 0, okay. What I'm trying to say is this part. See here, if you see the index number 5 and similarly the index number 6, these are empty. So for this case, this condition will become true. Okay, I'm just checking whether the length of graph of node is equal to 0 or not. That is, it is no, it doesn't have any outgoing edges. Okay, in that case also it is a terminal node. So what I will do is in the terminal node I will go to that index and I will change its value to 1. Okay, previously its value must be -1. Okay, since this condition was not true, okay, so it value must be -1, so now it will be made as 1. Okay, as simple as that, right? And we are also going to return 1. Okay, and in this case, next, if this is also not the case, okay, if this is also not the case, what you have to do, that means what are the conditions here? See, this node is not processed. With this we are sure, if this condition is not true, that means the node is not processed. If this condition is not true, that means the node is definitely not a terminal node directly. Okay, but it could be a safe node, it could not be a safe node. There are like still two possibilities there. So for that, what we are going to do is this: I'm setting a variable k. You can also call it as a temp variable. I'm initializing this is 1. Okay, or something like that. Now, if you see the way I'm doing it, see, if it is 0 means it is not safe node, right? So that I'm going to use now. See, I'm going to go through all the adjacent nodes of that. Okay, so currently I is going to tell me what are the adjacent nodes for the current node. Okay, for example, see here, for example, for the node 0, 1 and 2 are the next adjacent nodes. Okay, because 0 has a edge towards 1 and 2, so I will go towards all the adjacent nodes of the current node. Okay, I'm just checking if the I, that is the adjacent node, is a part of a visited setter node. Okay, visited set, if you see, it is already passed here. Okay, I'm just checking if it is part or not. If it is a part, okay, if it is not a part, if it is not a part, that means we have not visited that node previously. Okay, so I'll just add it here. Okay, and then I will start the recursive call. So what I will do, I will just do the recursive call, and now I will pass I. Okay, remember I was the adjacent node for the current node. Now I will become the primary node, and now we will explore the adjacent nodes of I. Remember I was the adjacent node of the current node, but when I do this function call, what will happen, I will now become the primary node, and now we'll explore the adjacent nodes of I. Okay, so that is what we are doing, and we are passing the visit set. Remember in the visit set we have already added I. Okay, as simple as that. Once we come out back from this function call, what we are doing, we are simply removing I again, because we have to now process the other possibilities, right? So I'm removing I from this. Okay, this is very important step. If you don't do this step, your solution will not work. Okay, as simple as that. Now see this part, this function call, just try to understand how this works. Okay, see, when you're designing a recursive solution, you'll have to keep many things here on mind, and you have to first of all design as like ideology for that. So as I mentioned, this function, okay, this particular function will always return 1 and 0. 1 means that the node is a safe node, 0 means that node is not a safe node. Okay, so what I'm doing for the current adjacent node, I am calling this function. So this function will either return a 1. If it returns, that means the current node is safe node. If it returns 0, that means the current node is not a safe node. So if a 0 is returned, 0 will be multiplied with k, and k will become 0 at last. Okay, so if if k remains 1 even for after this for loop, okay, if k remains 1 even after this for loop, what we will do, we will cache that value. That is, we'll go to terminal node array, and for this particular index we will mark it as 1. Okay, as simple as that, and the finally will return 1. Let's see the other case. Let us say as 0 is written. So what will happen, this will k will become 0. As you know, once k becomes 0, if you multiply any other number with k, still it will remain 0 only. Okay, so what will happen, k will become 0. After this for loop, 0 will get saved here, 0 will be get caching here to this particular index, 0 will be getting cached here, and finally will return 0. Okay, yeah, these are the two possibilities. Okay, now there is also third possibility. See here, if I is not in a state, okay, then we'll do this. Let's say I is in the visit. That means if you see what is happening, I will show you a condition where this will work. See here, we started from 0. Okay, now in the set I am having 0. Now I went to 1. In the set I am having 0 and 1. Okay, now I came to 3. So I have 0, 1 and 3. From 3 I am again going back to 0. So see, in the set already 0, 1 and 3 are there. Now I am again going to 0. Okay, so this condition will be executed now. Okay, see here, if I not in set, only then this condition will do. But in our current case, what is happening, I is there in the set already, so this condition will execute. What will happen, k is explicitly made as 0. Remember, here we are multiplying something with k, but here we are directly making k as 0, and we are breaking out of this, okay, loop. Okay, because now we know that, okay, this is not going to be a safe path, because it is now entering a loop. Please understand this path. A safe path is only possible if you're not entering a loop. Okay, once you enter a loop, a safe path will not be possible. That means the current node from which you started cannot be a safe node. Okay, because one of the edges is taking it to a loop path. Okay, taking it to a loop. So I'll do, we'll simply convert k to 0, and we'll break. Okay, so we'll come out of this for loop. So what will happen, if you see, the value will be cached here, that is 0 will be cached to this part, and we'll return 0. Okay, so one thing, please understand this part very clearly. This function will only return 1 and 0. Okay, these are the only two possibilities. Okay, -1 will not return -1 ever. Okay, as simple as that. So as you can see, what is happening, for example, let us say I am starting with a 0. Okay, I'm starting with 0. So what are the adjacent nodes, 1 and 2. Okay, you see for 0 it is 1 and 2. So 1 and 2 the function will be now called. Okay, now for 1 and 2 we'll now explore in else and node and so on. So what will happen is after each exploration, after each function call, that particular node's value, that is if it is safe or not, is getting cached to our this particular array. Okay, and we are not going to do that again. So if you see here, only the cache value will use after that. Okay, once the value is cached for a node, only the cache value will use after that. Okay, yep. That was the solution. Now if you see how I'm doing this function call, first time I'm going through each of the nodes from 0 to n-1, and then I'm starting this function call. In each function call I'm passing an empty set. Okay, because for each node you are supposed to start with a fresh set. Okay, as simple as that. If the value is already calculated and cached, so with this condition itself it will be written. Okay, as simple as that. If it is a a terminal node, then this condition will be returning. Okay, as simple as that. Okay, so once all those things are done, what we are doing, we are simply see here, I am again going back to see, once I have calculated this node, right, what will happen? Only those nodes, okay, only those intersects which are like a safe node will now have the value of 1 present in, okay, in it. Okay, rest of fields will be 0. Okay, as simple as that. Now what we'll do, we'll again go back to the whole array, and then we'll check if the terminal node for any index is I, sorry, if any index I is 1, then we'll simply append that node. Since we are going from 0 to n-1, so the order in which the values are getting appended is obviously in the increasing order. So remember, this was also a condition in the question. Okay, it has to be in the ascending order. So we are, even without sorting, we are able to get it in the ascending order, right? So this was the solution. If you talk about space and time complexity, see this part, we are maintaining this array, so this will take O of n time. Okay, other than that, if you see, we don't have any other data structure as such, but yeah, you will say that yeah, this set is being used. So at max what will happen is this set will at max have n elements. Okay, at a time it can only have n elements. Okay, after that it won't have n elements. So yeah, that also is some you can think of, like it also going to contribute n to the time, right? So overall it's going to be O of n solution. If you talk about the time complexity, see this part. While creating this is going to take O of n time. Okay. Similarly, if you see, this is also going to take O of n time. This is also going to take O of n time, right? And yep, even one more thing. See this part. If you see this case, okay, what we are doing is we are exploring each of the edges and nodes. So how many edges we are having in total in the whole array? We are going to have m edges. Okay. So overall time complexity is going to be around m plus n. Okay. It is going to be around O of m plus n, right? So this was the solution. So there is only one part which can be optimized further. See here we are using two loops. So what I will do is in the next solution I will optimize this. So see this part. In this section I've optimized it. As I mentioned, this function call will only return 1 and 0. So now I'm going to use that. Okay, see this with the single loop I'm able to do that now. Okay, here we were doing it in two loops. Now in the single loop I'm going to do it. Okay, what I'm doing the function call. If the function call returns 1, okay, if the function call returns 1, I already have the I with me. I'm going to simply add that I to the answer. Okay, answer is an empty list. I'm simply going to add that I to the answer if the function call returns 1. Okay, as simple as that. So then I'm returning the answer. In the previous case, what we have done, if you see, we were simply doing the function call, but we are not capturing the return value. Okay, so we have to again go back to the terminal node array, and check if the value is set to 1 or not. Okay, if you see, always the value is cached here, and only then the value is returned. Okay, so instead of capturing the return value, we are depending on this cache value. Okay, to get that we have to again run a O of n loop. Okay, but in this case what we have done, we have in the single loop we are also doing the function call, and at the same time we are capturing the value also, and if the value is 1, we are appending it to the answer list also, and finally we return it. So this was the solution for Python. This was the one of the most popular solution for Python. If you want a Java solution, let me show you that also. So here I've properly mentioned the comments. In Python also I mentioned it, but yeah, like okay, I did not save it basically, so it got deleted. But yeah, here I've mentioned the comments again. So see this part. This terminal node will have three states. -1 means the node is unprocessed. 0 means it is not a safe node, and 1 means it is a safe node, right? So this is the function. Okay, this is the function. This is the main function. So in this main function, let us quickly begin with that. What we are doing, I'm first of all see this. These are the two stuff that I'm declaring as a member of the class. That means it will be accessible from all the functions. Okay, since we're having to remember one thing, in Python we can have a function inside a function, but in Java that is not possible. Okay, so this has to be created as a private function separately. Okay, inside the class, not inside the existing function, right? So these are the two members of the class which can be accessed from both the functions. Okay, so first is the graph itself, second is the terminal node, right? Remember, terminal node is not initialized as of now. Okay, so in the main function, first I will initialize the terminal node. Since part, first I'm initializing them. Okay, it will have n values. Then if you see, I'm doing this dot graph equal to graph because graph is being passed here. Okay, as the input, but we have we have a graph as the data member. So I'm doing this dot graph is equal to graph. Then I'm getting the n is going to be the length of the graph. Okay, it will have n values, that is 0 to n-1. Then I'm doing this. I'm initializing the terminal node array. Okay, it will have n elements which are integers, and then I'm filling all the values as -1. Okay, as simple as that. Right. Remember, this condition is there, right? So you will have to keep them as -1. There's no other go, right? So you have to fill all the elements with -1, right? Then I'm declaring answer. Remember, in the if you see the return type of this is going to be list of answers. Okay, So in Python we have a list of this particular list. Okay, see, this was the data type, but yeah, in Java it is like this. Okay, list of integers. So you have to, I'm creating this. Okay, list of integers is equal to answer of new array list. Okay, I am passing n because it is going to have n values and last. Okay, at max it is going to have n values, right? Then I'm doing the same thing which I did in Python. I'm going through each of the elements. Okay, then I'm doing this function call. If this function call returns one, then I'm adding the type to the answer. Okay, and finally I'm returning the answer. So this is the function call. If you see, this is the function call. In each function call, what we are doing, we are passing I. At the same time, we are passing empty set. Okay, empty set, which is going to integers. Since I know that the set at max can have only elements, so I'm passing an also. Okay, as simple as that. So let us go to the function now. So this is the function. As you can see, I've declared it as a private because this will be accessible only inside the class. Okay, so that's why I don't want it to be accessed from outside the class, and there's no need also, right? And it is going to have int data type because it is going to return only 0 and 1, right? See this part. If node is already processed, return the cached result. Okay, so if the terminal node of node is not equal to -1, that is, it is processed either it returns 0 or 1 value, so return them. Okay, as it is now. If the node is a terminal node, cache the result and return 1. Okay, so if the, as you can see, graph the node, the length equal to 0, that means it is a terminal node. As I mentioned, the case of index 5 and 6. Okay, like this case of index number 5 and 6. Okay, these are going to be terminal nodes because they don't have any outgoing edges, right? In that case, what you have to do, simply make this value as 1 and return 1. Okay, as simple as that, right? If that is also not the case, we'll have to explore all the paths now. Okay, so I'm initializing k equal to 1. I'm going through that particular index, all the adjacent nodes of that particular node. Okay, and then I'm just checking whether it is not part of the set. If it is not part of the visited set, what I have to do, simply add it. Okay, for it, start another, do a recursive function call for the I. Okay, I is the adjacent node for the current node, so do a recursive function call for I. So this will tell me whether I is a safe node or not. Okay, because our current node depends on I, we have to first check whether I is a safe node or not. Okay, so this will tell me whether I is a safe node or not. Okay, so if we get to know I is not a safe node, what we have to do, see, this will return 0 or 1, right? If it returns 0, k will become 0. Okay, as simple as that. Once we counter this loop, we can simply do take visited. Just a second. Yeah, once we come out, just remove the ki again, because see, this visited got passed here. Okay, so once we come out of the list, okay, once we come back from the function call, simply remove I. Okay, again, otherwise your calculation will not work correctly. Okay, when you're exploring a part, only nodes involved in that part should be there in the visited set. Okay, so once you come out of that part, you should remove the I. Okay, as simple as that. And at last, I'm just, okay, if let us say I'm visiting a node which is already there in my visited set, that means we are entering a loop. Okay, remember, nodes are, if you see here, always all the values are going to be 0 to n-1 only. Okay, and yep, so there are see, just remember one thing, the nodes are never going to repeat. Okay, the values are always going to be between 0 to n-1. Okay, so that is the logic that I'm using here. Okay, so if a node is already existing, see, if this condition is not true, that means the node that you're visiting, okay, it is already existing. Okay, in our visited set. For that reason, we're entering a loop. So what we have to do, make k as 0 and break out. So once we break out of this whole for loop, okay, what we have to do, this is the for loop. What we have to do, whatever value we got, simply cache it here and return that value again. Okay, that's simple as that. So can you quickly tell me the only one addition that you can think of? See, I can think of is, see, once after this condition, you can add another if condition, that if k equal to 0, then simply break out. Okay, if k equal to 0, okay, what you have to do, simply break. Okay, yeah, just a second. Yep, simply break, because there is no need to continue further, right? As simple as that. You can simply break and you can declare that, okay, it is not possible, and catch the results. Okay, maybe you can try that out. Okay, I'm just leaving this for you. Okay, just I'm giving you idea. Maybe you have to do some more steps, because see, yep, if you break, then this part will not be executed. So just do that part also. Yep, maybe, yeah. If this follow is not getting executed, you don't need to do this part maybe. But I have to check that again, right? But yeah, you can just add this connection. Just try to understand how this will work. Okay, because if k once becomes 0, or if you multiply any other number also, it will keep remaining 0 only. Okay, so no need to continue further. That is my logic. So check that part also. And yep, this was the solution. It is a O of m plus n solution, and in space complexity is O of n solution, right? So Stefan, that was all for this video, and I hope you like my video. If you got anything to learn, please do subscribe to the channel. This really gives us a lot of motivation to continue further. See you tomorrow. Thanks a lot.